Welcome to the presentation. I am Louw, researcher at the Department of Horticultural Science, Stellenbosch University. In the next 5 minutes, I will share part of a larger project that investigates the influence of winter chill on apple fruit variability. The presentation, however, will be limited to quantifying possible sources of fruit variability using Golden Delicious as a model. In each of the next slides, you will find an icon in the bottom right-hand corner. If you click on this, a voice recording will take you through the presentation. We consider two climatically contrasting apple growing regions. Elgin's, the warmer region with 700 to 800 chill units in winter, versus the Koabokkerveld, the colder region with 1,200 to 1,500 chill units. We selected 11 Golden Delicious orchards in Elgin and 13 in the Koabokkerveld. Within each orchard, 2 branches from 6 trees were selected, and all the fruit were harvested as a single strip during the commercial harvest. At harvest, the fruit were removed and placed into specific categories to present the different canopy positions, such as fruit from the top versus the bottom of the tree, sun-exposed fruit versus shaded fruit, and fruit borne on spurs versus fruit from longer shoots. Harvested fruits were split into 2 groups. One group was tested immediately after harvest, and the second group was stored under regular atmosphere at -5 degrees Celsius for 12 weeks. All the fruit were subjected to maturity and quality analysis, including percentage starch breakdown, and this can be seen on the photos on the right-hand side, flesh firmness, size, mass, color, and levels of sunburn. In this way, we could now relate the maturity and quality of each fruit back to possible various causing components such as region, orchard, tree, or position in the tree. Let's look at the overall results. This graph indicates the percentage contribution on the y-axis that the individual quality parameters on the x-axis makes towards the total variability across all the measured fruit. If we look at fruit mass, for example, it shows that growing region accounts for close to 20% of the overall variation, and orchard differences account for a further 12%, and tree differences make up 15% of the fruit mass variance. The light yellow parts indicate sources of variation that were not captured by our experiment and remains unknown or unexplained throughout our methods. Hue and lightness refer to the color of the fruit, with hue indicating how green or how yellow the fruit is, and lightness referring to how bright the color is. It comes as no surprise that canopy position drives close to 40% of the sunburn variability, as fruit from sun-exposed positions are expected to show higher sunburn incidences. The lowest percentage of variability was identified and explained for firmness at harvest, illustrating the complexities that drive this trait. Over the next 2 slides, I will look into the regional effect on fruit aspect and the orchard and canopy position effect of percentage starch breakdown in more detail. From the previous graph, region was indicated as an important contributor to fruit aspect ratio. Let's investigate further. Fruit aspect ratio is a term used to explain the shape of a fruit. It is calculated by dividing the height of a fruit by its width, as indicated by the arrows on the apple on the left-hand side. The larger this value, the longer or taller the apple will be, and a smaller fruit aspect will thus indicate a rounder or flatter apple. When comparing the means of our fruit, it shows that fruit from the colder Koerbokkenveld region has indeed longer or taller compared to the rounder, flatter fruit from Elgin. Although some differences can be seen in the canopy positions within the 2 regions, it is the growing region, and thus possibly chill unit accumulation differences, that drives more than 30% of the variability. The graph on the right-hand side illustrates the regional differences further by showing the distribution of the fruit aspect ratio for the 2 regions. It confirms that most of the fruit of the Elgin region have a lower fruit aspect ratio and therefore appear rounder and flatter. For the starch breakdown parameter, we saw that orchard differences contributed heavily to the overall fruit variability. To investigate this further, I am presenting to you on the left-hand side the starch breakdown results from the individual orchards. The box in each plot shows the percentage starch breakdown of 50% of the fruit from that specific orchard. The cross indicates the average value for that orchard, and the lines show the range from minimum to maximum values obtained. We were surprised to see the huge amount of variation between orchards, especially knowing that producers aim to harvest at a starch breakdown percentage of between 15 to 20%. In the table on the right-hand side, we compared the mean starch breakdown percentage in terms of canopy position for the 2 regions. From this, it is interesting to see that fruit from the bottom of a tree in the Koerbokkenveld are more mature than fruit from the top. Small differences were also seen between sun-exposed and shaded fruit. This project provided us with a large data set of fruit quality, and we are hoping to mine this data more to identify trends and patterns to assist producers in minimizing the variability in their fruit. I would like to acknowledge Wardgrove Science as the funder of this research. I'd also like to thank the producers and the participants mentioned on this slide. Without their input and continued support, this project would not have been possible. Please feel free to contact me if you have any further questions. Thank you.